was Friday afternoon when I saw a green build containing my changes. And I knew I need to see this build on production before the weekend starts. At the same time, I had a gut feeling that it's a trap. And it's not only about the superstition about deploys, Fridays, and kittens. Because at the same project, a couple of weeks earlier, I deployed something to production, I broke it, and I had to stay late after work to fix it. And you know, after work, I have better things to do than fixing broken production. Really, I do. So I was sitting then there considering whether to deploy or not, right? I'm lying a bit. I just deployed it because I wanted to see it on production before I can go home at 5. You're probably thinking, this guy is strange, right? He's out of his mind. Deploying that late on Friday, why? Deploying just before the weekend. What is the project all about? And why was it so important to test it, to have it before the weekend on production? And last but not least, testing on production, right? Is it a proper thing to tell people on a conference? We'll get to that. But before that, we need to take a few steps back. I was working in a billing extraction project. We had this huge, majestic monolith. And out of this huge, majestic monolith written in Ruby on Rails, we had to extract a macro service, it was big, containing the whole billing domain. And we had to do it gradually, incrementally, without disruption, because we had hundreds of developers developing this majestic monolith and thousands of business users using it. So there could be no disruption, right? Because it's the money flow for the company. So we did it in an incremental manner. The first thing that we did, we put the billing code that was to be extracted in a separate module. It was still in the same process, and we used direct method calls to use it. And in the next steps, we decided to replace the database calls that were done with our nice ORM with external method calls that were done with our billing query service. Inside billing query service, we had a logic that was switching between the old direct call and new external HTTP call. It was still in the same process, but we wanted to check that the API works correctly. And to check it in a safe manner, we added 2 important things. The first thing was that there was a feature flag, so we were able to switch the traffic to the experimental HTTP API on percentage basis without an deployment. And the second thing was that we had a fallback, so that if the external call failed, we were switching back to the direct method call, so that the users see nothing more than a slight delay. And that was the starting point. Before we even started doing this API, we had safe deployment environment because we were able to switch on and off our new features without deployment. And in case something went bad, we had automatic fallback to something that works really well. So we deployed it to production, and we switched it for a small percentage of traffic, and we failed miserably. Really, the performance was abysmal, and we knew that we need to optimize it heavily. But instead of just optimizing the REST API, we knew that we need to do something drastic. We need something that's more versatile than REST. And we decided that in the middle of this big migration to a service, we need a small migration from REST that was correct but slow to GraphQL that will be hopefully correct and hopefully faster. We did one more thing before we started to optimizing the endpoints. We added better monitoring. We decided that our current monitoring is no-go and we need something better. So we added instrumentation of every single request we were sending to the billing service. We were logging not only the errors or the response time, but also the method that was called in the billing service, the parameters, and the stack trace in the monolith, so that we were able to reproduce every single slow request locally. And it gave us very short feedback loop during the optimization project. And before we even started the optimization, we had those two strong pillars. On one hand, we had very good monitoring so that we knew what we were doing. And on the other hand, we had strong deployment and strong and safe deployment environment. So we were able to roll back something if we did something wrong. And we started optimizing. The first thing was that we noticed that some of our views in web app and some of our background jobs were flooding billing service with thousands of requests. Why was it? This part of very innocent business logic had internal calls between the product that stayed in the monolith and the billing data that was in the billing. Before it was an optimized database call. Now we had single call to the external service in every iteration. It was very bad. And it was because we used this active object. Every time we need some billing data, we call a method, and it's calling billing. So instead of doing this fancy way, we moved the external calls one level higher. Instead of doing it on the data layer, we did it in the background job. And we added this small method, cache billing records, that did three things. First, it called the billing service, but not for a single product, but for a batch of products. Then it indexed the billing data based on product ID, and then it assigned those indexed data to the respective products. And because of that, we had a single billing call per a batch of products, so it was like 10 billing calls for a whole background jobs instead of 1,000. And that was a big win. Yes, we implemented a hash join on an application level, and it worked great. Now even MySQL has hash joins, and this preloading and caching really helped us. Next thing, similar. We were flooding our service with requests, sometimes hundreds requests per hour, but it was in separate places of the code, so we weren't able to cache it. So we wanted to take the cache on a higher level. We thought, OK, let's send the changes over Kafka, then build read models, then we'll query those read models in the monolith, and it will be great. And it was a fascinating project. I started implementing this. And then Samuel came. Samuel was our seasoned developer who knew the billing domain very well. And he said, nah, we have this data on the monolith side. And I must say that I was a bit angry. Because, Kafka read models, that's fancy. You can make a conference talk about it, right? And yeah, just querying database. Who could tell on a conference about querying databases? That's lame. But Samuel was a smart guy, so we listened to him. And instead of doing this Kafka thing that would take us a week or two, we spent 2 days talking to people that knew the domain and doing huge database queries to compare to databases. And we decided, yes, that's the way to go. And the solution, instead of, you remember, Kafka events, read models, querying, yeah, that was the single line, single query to the database. And it worked like a charm. What we learned here, that was a very important lesson, is that while technical proofness can help us winning the performance battles, the domain knowledge can let us avoid those battles at all. And that's far better. Next issue. We had the problem that some of the queries had non-deterministic response time. There were huge spikes in the response time. because we were fetching a lot of data. We started with a REST API that was small in size, with minimal surface, that was very simple. And it meant that we were sending everything that could be potentially needed from the billing to the monolith. And it also meant that we were doing filtering on the client side. Really bad, right? How bad? At times, we were sending hundreds of records to the billing service, from the billing service, to use a couple of them with a couple of fields. And it was the moment when GraphQL really shined. Because once we implemented all the types on the server side in billing, it was very, very easy to fetch only what was required, only the fields that were required to the server. And again, I was implementing this, and it was a very pleasant experience because the feedback loop was very short, and I saw the results of my work. I checked the slow calls on production in the logs. I reproduced locally. I applied the fix. Then I checked again locally that it's faster, and it was wonderful. And it was the same in this case. I merged it and deployed to production, and I was waiting to see the logs. And by the way, do you remember what was the hottest day of summer of 2020? The first COVID summer. I remember it vividly. It was Tuesday, June the 28th. On that day, I deployed the changes. I switched the feature flag. And then I was doing something else, watching Slack, and people were telling, oh, the background jobs has some problems. Yeah, OK. The staging deployment has some problems. Yeah, that's someone's problem. And then someone told me, that's your changes that broke the staging. And I said, nah. But I started checking. And in the afternoon, we had the business users in the US. So in the afternoon, business users started telling the platform behaves strangely. And then they told us the platform is down. And when I saw this message, the platform is down, I knew it was my changes that broke the platform down. I felt cold sweat on my back. It was the hottest day of that summer. Tuesday, June the 28th. How bad was this? It was really bad. It was terrible. We were using a couple times more of CPU than usual. We were using a couple times more of memory than usual. And worst of all, the database calls in an online database took a minute. But in the middle of those dark hours, two good things happened. The first time was the reaction of our infra team, because they reverted my change even before I had time to react. So everything was back to normal. And then they stayed with me after work so that I can fix it on master and deploy clean master to production. And then we saw that everything is OK. So I stayed after hours, but I wasn't alone. And the next good thing was my manager. He approached me the next day, and I thought, yeah, great. And he approached me, and he said, thank you, good job. Yeah, nice joke, right? And he was very honest, and he was explaining, yeah, you broke production, but that's OK in a fast-paced environment. You followed up, you fixed it, and that's OK, that these things happen. As long as you fix it, it's a good job. And I realized that's the part of the safe deployment environment, because I'm allowed to make mistakes as long as I follow up, and it's not the end of the world, right? So what was it all about? During this change, I did a small fix to improve data sanitization that were in the queries in the REST branch, the safe one. And I was sanitizing too eagerly. So I sanitized some params that should be sent. And in some cases, we weren't sending any params. And when we don't send any params, we don't add any wheres to the query. And as a result, we fetch almost the whole database. And we tried to send almost the whole database through the network. So that was really bad, and that killed billing. The fix was simple. I improved the sanitization, but I also switched the default. So when there are no params, we don't send anything. It's the opposite to the SQL, right? And when I deployed the changes, when it finally worked, it worked. The response time was better, it was more predictable, and that was what we really wanted to have. But what I really learned here, it wasn't the lesson about underfetching or server-side rendering, server-side filtering. It was about testing. We had very good unit tests, but it was testing only one param, the one that wasn't sanitized. We had integration tests, but we switched it to the unsafe GraphQL part, so the safe and tested REST part wasn't tested. And we had the feature flag switching between the safe REST and unsafe GraphQL, but the problem was that the issue was in the safe part in REST. So when I scaled down traffic on the feature flag to REST, it was even worse. And what I learned here is that I should always test something manually and give smoke test scenarios for my colleagues that are reviewing. Because with manual tests, we could have noticed that something is off. And without it, I broke production. And you know, if it was a novel or a film or a video game, it would be at the end of the story, right? Final castle conquered, final boss killed, we get the prize, we go home. But it was a real-life project. It's unlike a novel. After those climactic moments of being a hero and saving the production that you broke yourself, you just get back to work, and it was the same. We had another issue. Every week on Sunday evening or Sunday morning, we saw that requests were queuing in our reverse proxy up to the moment when reverse proxy, when the reverse proxy queue ran out of space and the proxy started answering 4 to 9 too many requests. That was a strange error, and we weren't able to reproduce it locally, because we didn't have the same environment locally as we have on production. So we had to test it on production. We noticed that that's our old friend that we called too many times billing in the same background job when we were scheduling some reminders. So yeah, we did the caching trick and hash index, and we deployed it to production, and we waited for Sunday. Yeah, that's the trick. And we saw the same error. So we realized that the problem is also during sending of the reminders. We thought it wouldn't be a problem because we were sending reminders per time zone. But unfortunately, most of our users were living in the same time zone, so the load balancing wasn't perfect. I was considering that maybe we could convince our users to spread around the globe, but I was told it's not possible. So instead of spreading the users around the globe, we spread the requests. Instead of sending all the reminders 5 p.m. sharp, we were sending them around 5 p.m. Within minutes before and after. It was a nice solution, and it worked when we were testing it, but on production it failed. Yeah, we realized that there is one more reminder that we missed, so we implemented jitter there, and we deployed to production, and we saw the same on Sunday evening. What was this? So our background queue had a resolution of about 15 seconds, and we thought that we split our reminders to 120 small buckets, but instead we were splitting it to 8 big buckets, and it was enough to saturate the queue and billing. So this time, we just read the documentation very well. We took what our background queue provides us, and we implemented normal rate limiting. And we deployed to production, and on Saturday evening, there were no errors. It worked. And it was during this project, during this task, when I saw a green build on Friday evening, and I realized I need to deploy it before I go home to test something on production, because otherwise I would have to wait a whole week to test my changes. And I deployed it, and I didn't break production. And I did it twice on the very beginning of this project, at on the very end. And now I hope that you understand what gave me the confidence to do this, why was it so important, and why the hell I was testing on production, right? And that was it. We learned a lot about the optimization. We learned various ways of fetching the data only the data that's needed by server-side filtering, by using local data, by underfetching. We also learned how to batch and cache the data from the other services. And we also learned how to spread the load. And when you take a look at the list, I think it's not very surprising or revealing, right? You probably know all those techniques. You've been using them for years in various contexts. What we did, we applied well-known patterns from the database worlds, patterns that we read on blog posts of other big companies. We applied them to our specific service-oriented infrastructure architecture. So you may ask, why didn't we do it well from the beginning, if it's so obvious, right? That's one of and the answer is threefold. The first is about simplicity. We started small and simple. We started with a boring solution with REST. And only when we realized that REST is the no-go for us, we decided to switch to something fancy, to GraphQL, to make the API more sophisticated. The second thing is learning. When you refactor code, and especially when you extract something to a separate service, it's very easy to break subtle performance optimization that you embedded in a previous code. And it's very hard to notice it just by staring at the code and just by unit testing. What we learned is that to see how the code performs, you need to apply the traffic of the production shape. As my long-term friend said, the real learning happens on production, not in development. And the third thing is about trade-offs. We wanted to implement something that performs very well because we were a technical team, but our colleagues from the feature team that was working with billing were hesitant to introduce the jitter, for instance, because they wanted to do, as it's stated in the requirements, send the reminders 5 p.m. sharp. And we had to explain them that it's impossible and that we need to spread the load a bit. And only when we convinced them it was legal to implement this. So I told you, so it was those three things: simplicity, learning, and trade-offs. That's why we learned it the hard way. So I told you what we learned in our project. I told you what mistakes we made. And now you can get back to your project, and you don't have to make our mistakes again. You can make your own mistakes. But when you do, please come back to a conference like this, or to your local meetup, or to your blog post, or to your company blog, and share your mistakes with all of us, because that's the way we all learn, by each other's mistakes. And if you're wondering if it's safe to do, if you can do it, and if you can learn by making mistakes on production, just think if you can deploy your changes on Friday afternoon. Thank you.